Hi, welcome to day 8 of 12 days of single message transforms videos and blogs. Yesterday we had a look at using the timestamp router to take the timestamp of a Kafka message and use it to mutate the topic name which was being used as we passed through Kafka Connect. Today we're going to stick with timestamps, but we're going to do something a bit different with them. Today we're going to deal with timestamps within the payload of a Kafka message. So quite often data will have timestamps within it and we might want to change their format. Or maybe a source system provides us a timestamp, but it's as a string, and strings are just like a bunch of characters which we hope form a sensible timestamp. Often we want to actually handle timestamp as a native timestamp object type. So we're going to use something called the timestamp converter single message transform. It's going to let us change strings into actual timestamps, or into dates, or into times. We can also use the timestamp converter to change an epoch value, like a big int holding the number of milliseconds since the Unix epoch back in 1970 something, and change that into a timestamp object, or indeed into a string if we wanted to do that. Let's have a look at the data we've got. It's in a source topic called Day 8 Transactions. I'm using Kafkacat here. Kafkacat's a really useful tool for poking around the data that you've got on your Kafka brokers. And I'm saying use Kafkacat. Here is my broker. The data's in Avro, so we're going to deserialize it with the schema registry that sits here. The key is a string, the value is in Avro. Here's my topic name. We're going to consume. We're going to start at the last 5 messages, and we're going to output it as JSON. Pipe it through JQ and just look at the transaction date within the payload. So here is the data that's in the Kafka topic. The messages are arriving in that source topic at a rate of about 1 a second, and you can see as it comes through we've got a string there holding what is clearly a timestamp. Now this is a well-formed timestamp. We've got no ambiguity in there as to things like the time zone, or if you've got kind of months and days and like is it month, day, or day, month, and you're not quite sure. We've got it nice and clear. We've got the time zone is specified, we've got the month is written out in alpha characters, so it's nice and easy to see what's going on. Oftentimes that's not always the case, and even here where it's nice and clear, we actually want to store what is a timestamp as a timestamp rather than as a string. This matters a lot when we start getting through to consuming the data, because if we push that timestamp down to a target system like a database or something, we want to handle it as a timestamp when it gets to that system. At the moment it's just a string. We can also see that if I clear that there, and we can also have a look at the schema that exists for that particular topic. So we're using Avro. I could use protobuf, I could use JSON schema. I'm using Avro to serialize the data as it's written into that topic. Because we're using Avro, the data on the topic is nice small binary compressed data, but the schema itself is held in the schema registry. If we saw in that Kafka Connect command that I ran, we pointed to the schema registry which sits here. So a consumer, Kafkacat in that case, connects to the schema registry and pulls the schema down so it can then deserialize that data correctly. And we can actually go to the schema registry directly ourselves to look at the schema. So here we're using a REST call against the schema registry. We're saying for this particular topic here in the value part of it, show me the latest schema. The schema comes out, let me show you, and it looks like this. So you've got the subject here, you've got the version, you've got the ID, and then you've got the schema. And the schema is actually JSON within the JSON payload. So we can use this nice little thing here, take the schema part of the message, pipe it through from JSON, a little function that JQ offers, and that gives us the actual schema. And we can see here we've got the card type, we've got the cost, we've got the transaction date, and all of these fields are strings. We've got a string, we've got a string, we've got a string. Now cost probably isn't a string, and we'll come to that on a different day when we look at a different transform called cast. Today though, timestamp converters. So here's our transaction date, and it's being held as a string. When we take that data and consume it or push it down to a target system with a sync connector, it's going to say it's a string, and it will create it as a string in that target system. So let's create ourselves a sync connector, which actually says, well, take in this data from a Kafka topic. For whatever reason, it's not being written as a timestamp to that Kafka topic, it's being written as a string. But as we egress that data down to a target system with a sync connector, let's route it through a single message transform which will fix that and actually treat it as a timestamp. So here's what we're going to do. To start off with, we're actually just going to show you what happens if we don't do that at all. So like going back a step, we're not using the timestamp converter. We're just going to say, take the data from that topic and stream it down to the database. So if we split the screen there and have a look at the MySQL and say show tables, we've got a table here called day 8 transactions, and we can say describe day 8 transactions, and it says this is what it looks like. And you'll notice the type of all of the fields is text. It's just a string, it's a var chart, it's just a bunch of data. We've got no type associated with it, or we've got a type, but it's a string. So we're going to say, let's use ourselves a timestamp converter, and this time we're going to create ourselves a new connector. So to the top of the screen now, and we clear that, and we say, here is my new connector. Let's move this down so we can see what's happening. And we're going to create a connector. It's going to have a -01 in the name suffix. So create a new connector using the same topic. And we've got two single message transforms. We're using a single message transform that we saw on a previous day, which is the regex router. Because if I take this and I try and push the same data down to the same topic, data from the same topic down to the database, it's going to try and write it to the same table. And we actually want to see what the difference is actually going to be here. So we're going to take that topic, and we're going to use the regex router, so this change topic transform label that I've got here. So change topic says use the regex router, take the entire topic name as it is, and append with TS to it. So with TS is just a hard-coded value. Now we use the timestamp converter. We say convert TS is our label, so it's got a type, timestamp converter. It applies to the value part of the message. You could use it in the key part of the message if you had a timestamp there. We say the field, transaction date, and what we're going to do is we're going to convert it from a string into a timestamp type field. So we say target type is timestamp. We can also convert it into a date, or into a time, or into an epoch indeed. If it was already a timestamp or an epoch and we wanted to convert it into a string, we could do that. And now the format here, because we're converting it from a string into a timestamp, the format is saying, well, what format is that string in? How do I pass that string? So you go to the Java documentation for date time and you find out all the different characters that you need to use to denote that particular value. So if I page up where we were before, this is the format of the message, of the timestamp that we're working with. So you have to go through and work out how do you represent like day of the week as 3 characters, and then month as 3 characters, and the date as 2 digits with a leading 0 if it's less than 10, and so on. So you come up with that date time format, which is this. So that tells it how to interpret that string that it can then take and convert into a timestamp. So we create that connector, and because we've got that regex router, we're changing the topic name, which means we're going to change the target table to which we're writing. So if we say show tables, it says, okay, you've got a new table now, day 8 transactions with TS. So describe the table, and now our previous 4 fields are exactly as they are, they're text fields. The transaction date, though, is, as we would really hope, it's a date time. It's an actual proper timestamp. And if we say select the transaction date, select transaction date and the item from that table, and it says, here you go, here are your proper timestamps as they should be, and then here's the other values and so on. But we've got the actual timestamp there as we actually wanted. The other things we can do with this converter, we can say go and create just the date or just the time, because sometimes you want to drop maybe the time element and you just want the date. So we can do that. We're going to create another instance of the connector. So let's page down there and clear this. And this looks like this. So again, we're creating a new connector. This time it's the 02 suffix. Again, same topic source. So we're actually consuming the same topic multiple times. And this is, by the way, one of the beauties of Kafka. You have the same data coming into the system. You can read it multiple times of independent connectors, and we can have another consumer somewhere else and a stream processing application, all reading that same data completely independently. So here's our topic. We're saying this time we're going to append with date to the topic name as it passes through, and therefore change the object name that gets created in the database. Our configuration for the timestamp converter is as before. So we say we're going to use this particular source field. It's in a string, so here is the format, the date time format of how you decode it. And now the target it's going to write it to is as a date. So it creates that, and it says we created it, and we go down to MySQL and we say show tables. We've got another table this time, as you would expect. And if we describe that, this time it's holding it as a date. So you've got these native data types that are being set correctly in the schema as it passes through, and therefore in the target system. And if we say select the transaction date, let's use that same select as we had before, select from here. So select the transaction date and the item, this time from the new table that we're populating, where transaction date is just the date part of the timestamp. You can see there's just the date part of the timestamp. But we're not just cropping the string down, we're actually saying here is a native date object type. And we can do the same thing with time. So let's do that for completeness. And we can say copy that in and put that here. So here's the -03 instance, same topic, we append with time this time to it, and we say the target type is time. We parse it in the same way before, the same format string. And in MySQL, let's go down here and say show tables. We've got our new table here with time. Describe the table there with time, and that's held as a time data type. And we do the select from here and we select it from there, and it says there is the time. So we've got just the time part of the timestamp that was coming through. The last part of the conversions that we can do is actually changing it into an epoch value. So an epoch is the number of milliseconds or microseconds, I can never remember which, since a date back in 1970, the Unix epoch, and that's going to look like this. So we clear the screen there and paste it in. This is, again, a new connector. We're simply changing the suffix that we're using on the connector each time. And we're saying the target type this time is Unix. Again, different topic name, modifying as it passes through, so a different object name we'll create in the database. So if we have a look at those connectors that are actually running, because I'm saying, like, let's just submit this thing and it works, and then look at MySQL and I'm going back and forth, back and forth. But if we just pause for a little moment and look at what we've actually set running here, we've got multiple connectors. We've got our source connector here, which is writing the data into the topic. And then we've got the first one here, which just streamed it through to MySQL unmodified. This one here changed it into a timestamp. This one here changed it into a date, into a time, and this one into an epoch. I should have probably used better connector names because 0, 1, 2, 3, and 4 is not particularly memorable. But the point is multiple different connectors reading the same stream of data independently and doing different things to the data as it passes through on the way to the target system. So if we head back over to MySQL now and have our final little check, show tables, we've got another table here with Unix epoch, and describe the schema of that there. And we can see it's holding it as a big int this time because that's what you hold the epoch as. And we can select it from as before and select those values with Unix epoch from that table, and there's the Unix epoch. So it's the milliseconds or microseconds, I can never remember which, since back in 1970, the Unix epoch. So that's how you use the timestamp converter. If I had Unix epoch in my source topic, I could convert that into a string or into a timestamp. If I had a Unix epoch in my source data in that source topic, I convert it into a timestamp or a string object. If I had a timestamp object in my source data, and for whatever reason I wanted that as a string formatted in a certain way in my target, I could also do that. The other thing to bear in mind here is I'm applying these transformations as the data leaves Kafka Connect, passing on to our target system. If our source connector is actually ingesting data and not setting it as the correct type, we may well consider applying this correction to the data at ingest. So let's give that a quick try. I've not actually tried this out before in practice, so it may actually go horribly wrong. But what we're doing is we've got a connector here called voluable. This is generating the data. It's still a source connector though. So whilst I'm generating dummy data, you can imagine this is a source connector pulling data in from a database or a flat file or a message queue or anywhere else where we can pull data in from using Kafka Connect. So here's our source connector, and let's see what happens if we add in that connector. So we're going to add in a transforms clause here, And I think we should probably just be able to use that same one that we used on the sync when we created it. So we're going to have a transforms value here. It's not as nicely formatted because I've not tried this before. I'm going to convert the timestamp here, and we're going to convert that, and we're going to do this. So we're saying transforms convert the timestamp in the value part of the message. In this particular field, it's in that particular format, and we're going to write it as a timestamp. What we're going to do is we're going to change the target name. Let's change the connector name as well. So let's call that 01. And then we're going to change the topic name to which it writes. So let's just call it 8A. And so now we've got a source connector writing data to a new topic. It's going to serialize it to a new schema on the schema registry. And if this works, we're going to take the source data from the source system, which was coming in as a string, and we're going to say, well, actually, let's store it as a timestamp because that's what it is. The benefit being anyone that then uses that data accesses it as a timestamp, which is what it logically is, rather than as a string, and each consumer, each connector has to then apply that transformation as it uses it. Let's set that running and see if it works. So we look at the REST API and see if things are working. And we've got our connector here, which says it is. So this is looking hopeful. And if we go and have a look at our schema registry here, we can have a look at the schema, and it was schema topic 8A, and we look at the latest, and we have a look at this here, and we page up, and we say, there we go. So transaction date, the schema for the transaction date, the type is being held as a long, so it's being held as an epoch, as a big int, and it's the number of milliseconds. It's just so someone knows what they're talking about. Number of milliseconds since the Unix epoch, and it is a timestamp. So if we route that topic now down to MySQL and don't apply any transformations to it, it should work. So cross your fingers and let's see if it does. So this is the name of my topic. Let's go and find on my bash clipboard, my bash history. So I'm using Control R, so let's cancel that and show you what you're doing. Control R searches back through your history. I know that it was a put, and we can do Control R again to keep going back. So we're looking here for 00. So this is day 800. Let's now go and do this. So it's just a quicker way, if you've got the commands on your history, you've typed them before, you can go around them, get back to the one you want, and then start editing it from there. So it's kind of quicker. Control E goes to the end of a line, Control A goes back to the beginning. So Control E there, and then go like this and that. So this should read the topic data from the new topic that we populated, and it should hopefully take that timestamp from the schema that's been held in the schema registry and write it down as a correct data type into the target table. We don't need any transforms to change the name of it because it's a different topic this time, so it'll get a different table name. And over in MySQL, let's have a look at that and say show tables. We've got a table called 8A transactions. We need a little virtual drum roll here because hopefully the schema has got the correct timestamp type in it. So it's always good when a plan comes together, and in this case that's actually how we should have done things from the outset in this particular scenario. So in this scenario where we have control over the data being loaded into a Kafka topic, and logically this TXN date field is a timestamp, then logically we should be setting it as a timestamp type in the schema so that any consumer then uses it correctly. If we don't have control over the source, or for whatever reason, if we want to change it per sync connector, then we can use this timestamp converter in the transforms in the sync connector to modify it each time we need to use it. So that is the timestamp converter. We can use it for converting between epochs and strings and timestamps themselves into epochs and strings and timestamps and dates, and however you want to work with your date time values. So subscribe to the channel as always, and stay tuned for many more talks and videos all about Apache Kafka and Confluent Platform.